Dear students, so in continuation with elliptic curve cryptography, in the previous video I have given introduction about elliptic curve cryptography and as well the key generation process. So now with respect to encryption, let us consider the message which we are about to send as M, represented with small case letter M. And as the first step, we need to represent this message on the curve. This we call it as mapping of the given message onto the given elliptic curve. Okay, so after mapping the message onto the elliptic curve, we need to consider a point M, capital M, on the curve. After considering the point M on the curve, we have to select K from the given curve. We need to select the value K from the given curve, right? And this K is within the range 1 minus n minus 1. This is within the range 1 minus n minus 1, which refers it is between 1 to n minus 1. So the K is in between the range 1 to n minus 1. And out of this values, the selected values K and the point M, we are going to create the ciphertext. So we'll be usually creating one ciphertext. Here two ciphertexts are generated, C1 and C2. So C1 is calculated using the formula K into P, and we know this K is the randomly selected value, and this P is your point on the curve. This P is your point on the curve. So for calculating C1, we'll be using the P value which we have selected initially and multiplying it with the randomly selected K value, okay, on the new curve where the message is mapped. Is that clear? And then we are generating C2. So for generating C2, we are using the formula M, that is your new point on the mapped curve. Okay, so M plus your randomly selected K value, okay, which is in between the range 1 to n minus 1, into your Q value. So what is your Q? Your Q is your public key. Your Q is your public key. So your M is your new point on the message mapped curve, and your K is the randomly selected number within the range 1 to n minus 1, and Q is your public key, and Q is your public key. So using the formula M plus K into Q, we will be obtaining the ciphertext C2. And now we are transmitting the ciphertext C1 and C2 to the receiver. Okay, and at the receiving end the decryption process happens. So the receiver needs to get back the original message M, which is or which was sent to him, right? So he'll be performing the decryption using the formula M equals C2 minus D into C1. Okay, so we know this D is our private key. This D is our private key. Initially we have discussed what is D, right? Yeah, so before starting encryption and decryption, the first process was to create key generation process, And in the key generation process, we have selected this random value D, which is your K, which is your key value, that is your private key, right? So we know what is this D. This D is nothing but your private key. And what is the C2? This is your ciphertext. And what is your C1? This is also your ciphertext. So we are going to multiply C1 with this D, okay, and that result will be subtracted from C2, which will actually give us the original message M. Okay, so the proof or the solving for this particular equation I'll continue in the next video.